Hello friends and welcome at my channel. Last time we were talking about domains, so let's conclude this topic maybe for the moment. I would like to show you a few more exercises, a few more solutions, and then I hope it will help you one day to just truly understand what's going on, at least if you are computing domains of logarithmical or some trigonometrical functions. All right, so let's give it a go. We'll see first of all I'm considering ln of, let's say, x squared minus 3x plus 2 divided over x plus 1. All right. So if we're talking about the domain of a logarithmical function, that means that the expression must be strictly bigger than 0. Okay, we're going to consider this in a moment, but we also have in the denominator expression x plus 1, which means 100% x shouldn't be equal to minus 1. All right, so minus 1 is for sure gone. Whatever will happen with the expression for the logarithm. Now we want it to be positive, so we have x squared minus 3x plus 2. Well, the best case is if the numerator, I really don't know, I haven't done it previously, so I'm just doing freestyle. All right, so x squared minus 3x plus 2, how can we solve it? Well, it would be better if we could cancel it. So if that would be possible to cancel x plus 1, the whole life would get easier. So let us see what are the 0 points of x squared minus 3x plus 2. Maybe you know the theorem of Vieta. So the product of those two must be equal to the absolute value, which is 2. So have two cases for the integers minus 1, minus 2, plus 1, plus 2, and their sum is 3. So it seems to be 1 and 2. So I can write it as x minus 1 times x minus 2, right? Seems to be fine. So obviously we cannot cancel it, no worries, but we now know so much more if we write it down this way. Why? Well, we can clearly picture the solution. Look at this. We have a parabola which has two 0 points. Firstly, it goes up. It's intersecting the x-axis at 1 and 2. It looks like this. So, and the denominator is x plus 1, which is such a function. All right. So, well, I even know I should be a little lower because that's supposed to be 2, as you can see. So something like this. All right. Okay. It's about sines in this case. So what do we know? We know that the parabola is positive all the time up to 1. With x plus 1, you see we're intersecting the x-axis at minus 1. So before we're having minus, so all the time from minus infinity up to minus 1, we're negative with x plus 1, so the denominator is negative, and the numerator is positive. So we clearly are in negative area, which isn't good for a logarithm, right? So minus 1 isn't allowed because of the restriction, so we're taking it out. Now, from minus 1 up to 1, where 1 is not included, because if 1 is the case, you see we're going to have 0. For logarithms, only positive values are allowed. So 1 isn't allowed, 2 isn't allowed either. But between minus 1 and 1, as you can see, the red parabola is positive. The blue line is positive as well. So x is allowed to live from minus 1 to 1. We're fine with that. From 1 to 2, the linear function is still positive, but the parabola is negative. And from 2 to plus infinity, both functions are positive. So that means if we are from 2 to plus infinity, we're good. So we have no situation where both are negative. That would be fine for our definition of logarithm because we would divide a negative number by a negative number, it isn't the case here. So we're dividing always positive by positive and never two negative numbers. Well, that's it. So the whole solution is x is from -1 to 1 united with 2 to plus infinity. All right? -1 to 1. Sorry. Okay. Now you can see it. That's the first one. Now I would show something about trigonometrical functions. Let us see second example. F of x is arcus cosine of 2x divided over 1 plus x. So first of all, before I start doing something with trigonometry, I just say, well, obviously x isn't allowed to be -1. So x isn't allowed to be -1 first. Now, if we look at the cosine leaves from, well, we start normally at 0, 1, and then we go like this, right? So this is the graph of the cosine, like this. That would be pi, that would be pi divided by 2, and that one would be 0. And exactly, so you see the cosine actually is a function. We are taking, what does the cosine function do? We're taking values from 0 to pi, and we are mapping them into the interval from -1 to 1. So that means our function, arcus cosine, so the inverse function of the cosine, is only defined here on this interval. So we're not allowed to be less than -1, and we're not allowed to be bigger than 1. So that means we want to solve this one. We want to solve 2x divided over 1 plus x is less or equal than 1. And now you see x isn't allowed to be -1. So we are, well, let us see. X isn't allowed to be -1, but the argument for the arcus cosine could be -1. Don't get confused, as I was confused 2 seconds ago. All right, so how can we solve it? Well, we have to solve just two separate inequalities and then combine the solutions. Let's start. So let's consider 2x divided over 1 plus x is bigger or equal than -1. So what can we do? Well, we said x isn't equal to -1, so it could be bigger, and it also could be less than -1. Now, I would like to get rid of the denominator, so I would like to multiply times 1 plus x in this case, but you see I have to be careful because if I'm doing so, I have to make sure that I know the sign of 1 plus x. Well, I'm sure it's not 0 because I took -1 out of the consideration, but it could be negative or it could be positive. So we have to go through cases. Case number I is x itself is bigger than -1. It's not allowed to be equal to -1, so it only could be bigger or less. If that's the case, then 1 plus x is positive, and case number I is leading us to 2x. We're multiplying an inequality by a positive number. That means we're not changing the direction of the inequality. We're bigger or equal than -1 times 1 plus x. I'm hoping not to make any kind of mistakes. Fine with that. So that means 2x is bigger or equal than -1 minus x. And now we can solve it for x. We'll bring it to the left hand side. We got 3x bigger or equal than -1. We divide it by 3, and we get x bigger or equal to -1/3. Now, what was the assumption? The assumption was x is bigger than -1. So we want to be, this is -1, We're bigger than that. And now we want to be bigger than minus a third, which is a bit closer to 0. And we are going from there on. So the solution is x is bigger than minus a third. And now the case second I, that would mean that second or two i's, that means x is less than minus 1. If x is less than minus 1, we're multiplying times a negative number, so we're changing the direction of the inequality. That means we got 2x, it's less or equal, it was bigger or equal, then now minus 1 times 1 plus x. So basically the same, but we are changing the direction of the inequality, and now we're having 2x less or equal than minus 1 minus x. We're having 3x less or equal than minus 1, which means x is less or equal than minus a third. The conditioning for this two i's was x is less than minus 1. So we want to be less than minus 1. This is minus 1. Not taking this, we're less. And now we want to be less than minus a third. So we're less than minus 1. So now, what is the solution? Well, let us see what do we have in those two cases. So the first case was telling us, you see it was case I, and we wanted x to be bigger or equal than minus a third, and we wanted to be bigger or equal than minus 1, so it was a solution for the first case. But remember, we also have the second case, and we must be fulfilling both cases at the same time. So the second case is telling us we are less than minus a third and we're less than minus 1. So the solution was, in order to fulfill them at the same time, is to take minus 1. So we want to be less than minus 1, and we also want to be bigger or equal than minus a third at the same time. So that means that's minus 1. We want to be less than this, and we want to be bigger or equal than minus a third. They never meet. So that means no domain, no definition. So the domain is empty. Our expression isn't defined. I hope I made no mistakes. And the last case, which I'm showing you, is the arcus sign of a logarithm of, let's say, to the base of 10, whatever, of x divided by 10. So now we have a composition of functions. And first of all, this expression must be positive. So that means x must be strictly positive. Now, we are talking about the base of 10. Arcus sign, once again, the sign isn't defined in order to inverse it from 0, but from minus pi divided by 2 up to pi divided by 2, because this is exactly where the function is bijective, between minus pi divided by 2 and pi divided by 2 onto minus 1, 1. So once again, it's about being between minus 1 and 1. So we want a logarithm of x divided by 10 to the base of 10 to be less or equal than 1 and bigger or equal than minus 1. All right, so can we simplify it somehow? Yes, we could. We could rewrite a logarithm of x divided by 10 to the base of 10 as logarithm of x to the base of 10 minus logarithm of 10 to the base of 10, which is 1. So basically we have minus 1 less or equal than a logarithm of x to the base of 10 minus 1 less or equal than 1. Now we're adding 1, and we are getting to 0 less or equal logarithm of x to the base of 10 less or equal than 2. That's the story. So if we consider now, so let me write it again, logarithm of x to the base of 10 less or equal than 2. That's the story. So if we're considering the logarithmical function once again, well, we have the y value of 0 if we're considering 1. So x needed to be bigger than 0 previously, but now we go further and we see x must be bigger or equal than 1 in order to fulfill this inequality. What about 2? Well, this is somewhere here. What means somewhere? It's 100, right? Because if we have a logarithm of 100 to the base of 10, it's going to be 2 because 10 squared is 100. So x is bigger or equal than 1 and less or equal than 100. And that's the solution. Okay, I hope it was clear. I was showing 3 cases now, and it was my last video of this year. See you guys in the next year, and maybe I'll do a few more domain examples. I do not know yet, but I'll figure it out tomorrow. Okay, all the best, stay healthy, and be successful in mathematics and in your whole life, whatever you're doing. Bye-bye.